So let us start our discussion. So we have seen so far our concepts in supervised machine learning. What are the concepts that we have seen? Simple linear regression, multiple linear regression, and then a logistic regression we have seen. So these are the topics what we have discussed. Now, all these topics are examples for our supervised machine learning algorithms. So today we are going to start with our unsupervised machine learning concepts. So the first concept what we are going to see is clustering. So what do you mean by unsupervised machine learning? When we are not aware of our target variable. When we do not have our target variable, then those kind of problems can be called as your unsupervised machine learning problems. When you are working on unlabeled data sets, that is called as unsupervised machine learning problems. So the first topic what we are going to discuss is called as clustering first. So we are going to start with the basic understanding of clustering, and then we are going to discuss what are the important concepts that we have to focus when we are applying the concept of clustering. That is what is the agenda for today. So first, what do we mean by clustering first? What do we mean by clustering? Clustering is grouping of your observations. Clustering means grouping of your observations together. That is called as clustering. All my similar observations that I have in my data set, I can group them together and I can form one cluster. This is the idea. So for example, if you have the list of patients in your hospital, you have list of patients are there. Then you want to group all your observations, all your patients who are having A positive blood group in one cluster. You want to group all your patients who are having B positive blood group in one cluster. You want to group all your observations, all your patients who are having O positive blood group in one cluster. So all your similar observations, we are going to group them together in one cluster. That is the idea. Suppose you have a list of schools, and then you want to group your list of schools into different clusters. All the schools which are having ICSE syllabus, this is one cluster. All the schools who are having CBSE syllabus, this is another cluster. All the schools which are having state syllabus, this is another cluster. So it is grouping of similar observations together. That is called as clustering. What is the another example? You can group all your countries into clusters based on what is the currency they are using. All the countries which are using dollar as a currency, that is one cluster. all the countries which are using euro as a currency, that is one cluster. All the countries which are using pound as a currency, that is another cluster. So grouping of similar observations together, you can call that as clustering first. So like this, many applications are there. One by one, we are going to discuss what are the applications of your cluster. So broadly, the two common types of clustering concepts, what you are going to observe, are hierarchical clustering and K-means clustering. These are the two common types of clustering techniques, what you are going to come across. So we are going to discuss hierarchical clustering as our first topic. So we are going to see what are the different concepts involved in hierarchical clustering. That is what we are going to discuss today. So keep all the concepts what we have discussed so far at the back of your mind. We are again going to revisit those concepts. So grouping of similar observations together. What is a simple real life example that we have? Your dabbawalas in Mumbai. They distribute your lunch boxes. So what do? They segregate all your lunch boxes based on the location. So where they want to distribute their lunch boxes. So for every location, they are going to create a cluster first. So they are going to collect all the lunch boxes which have to be distributed to one particular location. And they will assign one person who is going to take care of all these lunch boxes. Similarly, they are going to assign another person to some other location. So all the lunch boxes will be distributed by this person in that location. Then similarly, they are going to assign another person to one more cluster based on the location for distributing the lunch boxes. Then this person is going to take care of that location. So in this way, they are segregating all their lunch boxes into different clusters first, based on the location. So they are grouping all the similar observations into one cluster. And they are going to assign one person who is going to take care of those cluster. And he is going to distribute all the lunch boxes which are there in that cluster. So this is a practical application of our clustering algorithm. This is our practical clustering application. Now, we are going to see many such real-time applications for our clustering model in a few minutes. So what is the definition of clustering for us? Clustering is a data segmentation technique. It is an exploratory method for identifying your homogeneous groups of records. So explore your data, find out what are your similar observations in your data, and simply group them together. And you are going to form your cluster. So if I have a portfolio of stocks, what I can do? I can put them into different clusters based on what is the return they are going to give me in 1 year. All the stocks which are giving me return of less than 5%. This is one cluster. All the stocks which are going to give me return 5 to 10%. This is another cluster. all the stocks which are going to give me greater than 10% return in 1 year. This is another cluster. A, B, and C. So this can be another practical application for our clustering model. So similar records should belong to same cluster. All the stocks which are giving you less than 5% return should belong to this cluster. All the stocks which are going to give you between 5% and 10% return, they should belong to this cluster B. All the stocks which are going to give you more than 10%, they should belong to cluster C first. So similar observations should belong to same cluster first. The dissimilar observations should belong to different clusters. So all the patients who are having A positive blood group should belong to this cluster. All the patients who are having B positive blood group should belong to this cluster. All the patients who are having O positive blood group, they should belong to this cluster. So A positive blood group people should not fall in different clusters first. All my patients who are having A positive blood group should only fall in one cluster. So all my similar observation should belong to the same cluster. Dissimilar observations, they should belong to different clusters first. They should fall in your B positive cluster or O positive cluster. That is the idea. That is the purpose of clustering. That is what we have to do. That is what we are going to do using the concept of clustering. So clustering, what is another name for clustering technique? You can also call it as segmentation first. So another name for clustering, you can call it as segmentation. Or you can simply call it as clustering analysis first. So what is clustering? Grouping of similar observations together. It is grouping of similar observations together. This is what we have to understand. So why clustering is done? Because you want to understand what is the structure present in my data set. I want to understand what is the pattern present in my data set. I want to understand what is the structure, what is the pattern present in my data set. That is the primary purpose of performing your clustering concept. Now, also summarize your observations by their cluster center. So you can study and find out what is the characteristic of our cluster. By understanding about your cluster center. So you can comment on the characteristics of your observations which are present in one cluster based on the cluster center. Suppose if I have my set of observations here, all my observations are different universities. Why these universities are grouped together? Because all my universities are requiring one common SAT score required or common GMAT score required. So this common GMAT score is somewhere in the range of 650 to 750. So all these universities are grouped together because all these universities are requiring a GMAT score in the range of 650 to 750. So if I take the average roughly for all the universities, what is the GMAT score? Then I can find out that it is 700. So based on the cluster center, what is that I can understand? If I want to apply to all my universities, I have to get an average GMAT score of 700. Only then I can apply to these universities. So based on the cluster center, you can understand the characteristics of your universities. That is the idea. You can summarize all your observations, all your universities who are falling in that cluster by their cluster center. On an average, what is the GMAT score required for all the universities falling in our cluster? It is 700. So if I get a score of 700 in GMAT, then I can definitely apply to these universities and I can wait for admission. So that is how we are going to take our decisions. So this is a simple concept which is going to give you some clarity of how to use our clustering concept and take our business decisions. That is the idea. This is the purpose why we are using our clustering concept. So what is another common example that all of us know? It is the concept of periodic table. Where have you studied this periodic table? In chemistry in 7th standard, you will come across for the first time this periodic table concept. So what is this periodic table telling us? It is organizing all the elements into respective clusters based on properties. So if you look at this cluster 8A, it has grouped all the similar observations. It has grouped all the elements into one cluster 8A group based on the chemical properties of these elements. What can you call this 8A group? It is having elements like helium, neon, argon, krypton, xenon, and all. What are these? Noble gases for us. So this is one cluster, group 8A, or you can write it as noble gases. This is what you can write. Now, what about group 7A? It has segregated, it has grouped all similar observations together based on their chemical properties. And it has created one cluster called as 7A. What are the elements? Fluorine, chlorine, bromine, iodine. All these elements are there. So what is this group? Group number 7A. So this group number 7A is called as our halogens. If you remember chemistry, then you will understand this group was called as halogens first. Group number 7A. What about group number 1A? What are all the elements that we have in group 1A? You have lithium, sodium, potassium, rubidium, cesium, and francium. So all these are elements belonging to one cluster 1A for us. What can you call this cluster? You can call this cluster as alkali metals for us. That is one cluster, alkali metals. Then, what about group 2A? This is one cluster for us. What are the elements that you have in group 2A? Beryllium, magnesium, calcium, strontium, barium, radium. All these elements you have in our group number 2A. So this is another cluster for us. They're grouping all your similar observations, similar elements together. So what is this group called as? Alkaline earth metals. So like this, your periodic table is organizing all the elements into the respective clusters. Like this, you have many clusters. You have lanthanide series. This is one cluster for us. You have actinide series. This is another cluster for us. You have non-metal cluster. Carbon, nitrogen, phosphorus, silicon, selenium. So all these are different clusters for us. So you have another semi-metals cluster. You have silicon, boron, arsenic. All these things you have. Polonium. So your nature is organizing all your elements into their respective clusters. So nature is naturally organized. Nature is also capable of forming our clusters. That is what we have to understand. That is important for us. So this is another common example which will give us a lot of clarity in understanding how your clustering concept is going to. So there are many such applications for clustering. Many applications are across different industries, across different sectors. Many clustering applications you are going to find. Now, what are some of the applications? For example, you can cluster the type of pages that are there on the web or internet. Then you can also cluster type of customers who are there in your market. You can cluster them into value added segment. This is one cluster for us. Then you can also segregate your observations into another cluster. You can call this as your luxury segment. Then you can also cluster all your observations into another cluster, which is called as premium segment for us. So you can cluster your market into three different segments: value added segment, luxury segment, and premium segment for us. So you can do this. You can also cluster your types of people who are there on the social network. You can cluster your types of emails in your inbox, whether their emails are belonging to your spam category or the emails are belonging to not spam category. So you can have two simple clusters like this. And you can also cluster your types of genes the human genome has into your different clusters. So all these applications are there where you can use the concept of clustering first. So keep these concepts at the back of your mind. They are useful examples for us. So just 1 second. So that is the idea. Now, what is the first type of clustering we are going to see? It is called as hierarchical clustering concept. So hierarchical clustering is what we are going to see. So in this hierarchical clustering, the important concept is the concept of dendrogram. So this dendrogram is going to look like a tree for us. This dendrogram is going to look like a tree for us. Tree. So if you want to visualize your dendrogram, it is going to look something like this. This structure, what you are seeing on the screen, is called as a dendrogram force. Dendrogram. Now, what is this dendrogram trying to do for us? It is trying to group all your similar observations together. And then you can form your clusters. So these are all your similar observations which you can group them together. And you can form your clusters. That is the idea. So most commonly, you would have seen this kind of structure when you are working on a simple concept like family tree. There you have seen this kind of structure. So if you want to create a family tree, then you are going to make use of a structure which is going to look similar like your dendrogram force. A structure which is going to look similar like your dendrogram. So from your dendrogram, what is that you can do? You can form your clusters. So the concept of hierarchical clustering is going to make use of our dendrogram. And with the help of dendrogram, you can create your clusters. That is the purpose, that is the objective, what you are going to see. So you have to understand the concept of dendrogram and you have to understand how to create your dendrogram. How to create your dendrogram, you have to understand. So let us see. Let us study what is a dendrogram first, and later on we'll try to understand how to create our dendrogram structure. So hierarchical clustering is a type of clustering which makes use of a concept called as dendrogram first. Dendrogram is nothing but it is a tree-like structure. It will have some hierarchy. That is what we have to understand. And using this hierarchical structure, you will be in a position to form your clusters. We will be in a position to create our clusters. That is what we have to understand. Now, we have to understand what is another name of hierarchical clustering. Another name of hierarchical clustering is called as agglomerative clustering for us. It is called as agglomerative clustering. So slowly I will explain you why your hierarchical clustering is also called as agglomerative clustering for us. We'll try to understand what is the reasoning behind why it is called as agglomerative clustering. So let us see first how your hierarchical structure is going to look like. So this is how your hierarchical structure is going to look like. So how are you going to create this structure? What is the first starting point for us? You have to understand that you have to group similar observations together. So first find out what are your similar observations in your data set. First find out what are your similar observations in your data set. First find out that. Now, similar observations are M and W first. M and W can be siblings. They can be sisters or they can be brothers. They are going to have one common set of parents. Another two similar observations can be N and U for us. They can be another set of siblings for us. They are going to have a common set of parents. So first you have formed these two clusters first. Then what is that you can do? Because you are having similar set of parents for M and W. You are having similar set of parents for N and U. So these two parents must be siblings. P1 and P2 must be siblings first. So what is that I'm doing? I can also group them together. And I can say P1, P2 are going to have common set of parents. Grandparents, I can call them. So what is that I'm doing slowly? Slowly, I'm trying to aggregate my information. Slowly, I'm trying to aggregate my information from the bottom to the top. What is that I'm trying to do? I'm trying to aggregate my information. I'm trying to collect my information. My M and W are similar observations. N and U are similar observations. And if these observations happen to be cousins, then what I can do? I can group all four observations together in one cluster. So slowly I'm trying to accumulate my information. I'm trying to form my clusters. That is what I'm trying to do. So what is your first objective? You have to find out what are your similar observations in your data set. What are your similar observations in our data set that we have to find? And then group them together. Let us take a look at another example. Your observation 0 and 5. These observations are similar, if that is what you have discovered from your data set. Observation 3 and 8 are also similar. That is what you have also discovered. Now, after doing this, if you also discover that 3, 8, 0 and 5, they are all similar observations. What you can do? You can group all your observations together and you can form one cluster. So that is what I'm doing here. So simple example for this is 0 and 5 are two students who are studying data science. They are in my morning batch. 3 and 8 are other students who are studying data science. They are in my afternoon batch. So they are similar. I can put them together. They are similar. I can put them together. Now all four students, I can group them together and I can call them as data science students. So what I can do? When I'm issuing project to my data science students, I can simply group all these four observations together. I can put them in one group and I can give them the project. because all four of them have learned data science and they are in a position to take up the project. That is the idea. That is how you are going to form your clusters. So you are aggregating the information from the bottom to the top. So it is a bottom-up methodology what you are using to develop your dendrogram structure, to develop your hierarchical structure. That is what you are doing. That is what we have to understand. Let us take a look at another example that we have. What is another example? Suppose you have 6 observations. A, B, C, D, E, F. A is America, B is Bangalore, C is Chennai, D is Delhi, E is Punjab, and F is Mumbai. So different places you have. So Bangalore and Chennai, I can group them in one cluster. I can call it as South India cluster. So it is possible we can do this. Delhi and Punjab, I can group them together. I can put them in one cluster. And I can call it as North India cluster first, because they are present in North India first. Now F is Mumbai. What can I do in next step? Because F is also very closely affiliated to our North Indian cluster. You have people from Gujarat who are residing in Mumbai. So Mumbai also I can consider it as part of my North Indian cluster. This is also North India. Now, what is the next thing I can do? I can combine my South Indian cluster and I can combine my North Indian cluster together and I can call it as India. This is my India cluster. Then what more I can do? I can combine my America and India together and I can call it as world. This is another cluster what I can create, where I'm grouping all my observations together and I'm calling it as my world cluster. So in this way, starting from the bottom to the top, I'm able to collect, I'm able to aggregate the information step by step. We are trying to merge all our observations step by step. And we are creating this dendrogram structure for us. That is what we are doing. So because we are aggregating information from the bottom to the top, and we are able to develop this hierarchical structure, your hierarchical clustering algorithm is also called as agglomerate clustering model. That is the reason why it can also be called as agglomerative clustering model. So what is that we are doing? We are starting with n observations, 6 observations, and then 2 closest records. You are merging them into one cluster first. Bangalore and Chennai, you have put them in one cluster. Punjab and Delhi, you have put them in another cluster. And at every step, what is that you're doing? We are trying to pair our clusters which are having the smallest distance. We are trying to pair our observations which are very close to each other. So what have you done? To your North Indian cluster, you have added one observation Mumbai. So we have added one single observation to our existing cluster, North Indian cluster. Then what you have done? You have combined our 2 clusters, South Indian cluster and North Indian cluster. You have combined B and C, you have combined D and F together. and you have formed one cluster B, C, D, E, F. So that is how you are able to create this hierarchical structure first. That is how you are able to create this dendrogram. So what is the most important thing for us here? What is the most important thing that we have to understand? We have to focus on similarity between our observations. Similarity. So how can you understand the similarity between our observations? We have to focus on the concept of distance first. We have to use the concept of distance. So distance measure is going to help us understand what are the similar observations that you have in your data set. That is what you have to focus on. Distance observations. Now to summarize whatever concepts we have seen so far. We have tried to first identify whether our observations are similar or not. Your Bangalore observation, Chennai observation are similar, and you have grouped them together because they are very close, and then you have called it as cluster A. Then Delhi and Punjab, we have grouped them together initially because they are very close to each other, and you have formed your cluster. Next, what have you done? Mumbai also, you have discovered it is closely affiliated to your North Indian cluster. So you have grouped your Mumbai observation also to our North Indian cluster, and you can call it as cluster B. So both your clusters you can combine and you can call it as India cluster. So India is a combination of South India and North India. So when you're creating your dendrogram, on your x-axis you are going to have your observations. Your observations are going to be on your x-axis. And on your y-axis, you are going to have your distance or similarity. That is what we have to understand. So on x-axis, you are going to have your observations. And on y-axis, you are going to have your distances. Now, what are these black color vertical lines, what you're seeing here? What are these black color vertical lines? They're called as linkages. This black color line is called as linkages first. Now we have to understand also the concept of linkage. So first we have to understand the concept of distance, and then we have to also focus on linkage. So in simple terms, what do you mean by linkage? How do I know that Mumbai observation should be clubbed with your North Indian cluster? How do I know that Mumbai observation has to be linked with our North Indian cluster? Why can't I link my Mumbai observation with my South Indian cluster? So to understand that, we have to study the concept of linkages first. So under linkages, we are going to discuss three types of linkages for us. One is your single linkage, one is your complete linkage, and another is your average linkage. And also, we are going to study centroid linkage. So all these different types of linkages we are going to discuss. And before that, we are going to discuss first the concept of distance first. What is distance? How do you find out the distance between our two observations? This is what we have to understand. So to find out the distance between our two observations or two records, first we have to discuss what are the properties of distance. Before we find out what is the distance, let us try to understand what are the properties of distance. How are you supposed to interpret the value of distance? That is what we are going to discuss. So if you are trying to compare two observations, I and j, how can you define the distance between I and j observations? You can simply define using the notation of dij. This is the notation what you are going to use to indicate the distance between our observations I and j. It can be our two records, Bangalore and Chennai. It can be our two observations. So what are the different properties of distances that we have to understand? Distance can never be non-negative for us. Distance can never be non-negative. So you have to ensure that distance value is greater than 0 between our two records. So that is the first property of distance first. What is the second property? Distance between similar records is going to be equal to 0 for us. So distance between Bangalore and Bangalore is 0. Distance between Chennai and Chennai is 0. Distance between myself and myself is 0. So distance between similar records is going to be equal to 0 for us. Then what is the next property? Symmetrical property. What is our symmetrical property telling us? Dij is equal to dji. So distance between Bangalore and Chennai is same as distance between Chennai and Bangalore. So dij is equal to dji. This is called as symmetrical property for us. Distance between ij will be same as ji. Next, you have triangle inequality property. What do you mean by triangle inequality property? I, j and k. Dij, djk and dik. So the sum of distances between two sides of your triangle will always be greater than or equal to your third side of your triangle. So sum of two sides of your triangle will always be greater than or equal to third side of your triangle. So dij plus djk will be greater than or equal to dik. So this is what we have to understand. Distance between any pair cannot exceed the sum of distances between other two pairs. This is your last property. So when you're finding out the distances, you have to keep all these properties at the back of your mind and then interpret the distance value. That is what we are supposed to do. Now my question is, how are you going to calculate the distance between our observations? If I give you two observations, what is the formula that you are going to use to find out the distance between our observations? What is the most famous formula that all of us are aware of when we are trying to find out the distance between our observations? What is the formula that you have discussed in coordinate geometry first? The most famous distance concept that we have studied in our coordinate geometry. What is it called as? It is called as Euclidean distance. Euclidean distance. So what is the formula when you have 2 points? What is the Euclidean distance formula? Root of y2 minus y1 whole square plus x2 minus x1 whole square. This is our most famous Euclidean distance formula. Suppose if I give you x1, y1, z1, x2, y2, z2. What is the formula? Root of y2 minus y1 whole square plus x2 minus x1 whole square plus z2 minus z1 whole square. So this is your Euclidean distance. This is your distance between two records, I and j. Suppose if I give you x1, y1, z1, d1, x2, y2, z2, d2. What is the formula? Root of y2 minus y1 whole square plus x2 minus x1 whole square plus z2 minus z1 whole square plus d2 minus d1 whole square. So to find out the distance between our observations, we are going to use the concept of Euclidean distance. And distance is going to give us information about the similarity. How similar are our observations? The closer they are, the more similar are our observations. So no need of any manual calculation in Python. Simply you can say metric is equal to Euclidean. And then it is going to apply your Euclidean distance formula in the background. And it is going to find out the distance between our observations. So that is the first step what you are going to discuss. That is the first concept what we have to understand. So far, remember all the concepts what we have discussed in case of a hierarchical. So remember what are the properties of distance and how are we calculating our distance. So now we are going to take a break here for about 10 minutes. And then after the break, we are going to come back and we are going to study the concept of linkages. And then we are going to see one example case study. And we'll apply all our concepts what we have discussed. So take a break for 10 minutes. And then after the break, we are going to discuss our linkages. So let us continue our discussion. We have talked about the concept of distance. That is what we have seen. Now let us continue our discussion on the concept of linkages first. So what are the different types of linkages we are going to study? We are going to study what do you mean by single linkage? What do you mean by complete linkage? What do you mean by average linkage? And centroid linkage. So now, single linkage, let us try to understand first. It is also called as nearest neighbor concept. So, if you want to find out to which cluster my observation X has to belong, whether it should belong to my red color cluster or it should belong to my blue color cluster. If you want to find out, what is it you are going to do? You are going to find out what is the minimum distance between the members of my two clusters. So these are all your members of your cluster. Now, what is it you are going to do? You are going to find out the distance of your observation X with members of both your clusters. You are going to find out the distance between your observation X and members of your red color cluster, members of your blue color cluster. And then based on the minimum distance, you will decide that to which cluster your observation X is going to belong based on the minimum distance concept. If this red color observation is having a minimum distance with this observation, then you can put your observation X in a red color cluster. So based on whatever is the minimum distance between the members of your two clusters, you are going to assign your observation X to that cluster. This concept is called as single linkage first, or you can call it as the nearest neighbor concept. So it is based on minimum distance between the members of your two clusters, X and Y. So when you are trying to apply your single linkage in Python, you can simply say linkage is equal to single. And I can apply my nearest neighbor concept. Now, if you go back here to our dendrogram structure, now, if you want to decide your observation Mumbai has to go to which cluster? If you want to find out how should I link my observation Mumbai, then I can simply use the concept of single linkage and find out who is my nearest neighbor. If my nearest neighbor is belonging to cluster B, then I can link my observation 3 with observations which are present in cluster B. That is what I can do. Based on my nearest neighbor, if 4 happens to be my nearest neighbor, then I can link my observation 3 along with 4 using the concept of single linkage. That is the idea. That is the logic. That is what you are going to do using the concept of nearest neighbor. Now, I'll ask you another question. What is complete linkage? Complete linkage is the concept of farthest neighbor. So this concept is based on the greatest distance between the members of 2 clusters. It is the opposite of your single linkage. So if you want to find out where this observation X is going to belong, is it going to belong to your red color cluster or is it going to belong to your blue color cluster? It is based on the greatest distance. So what is that you can do? This observation X is having the greatest distance with this blue color observation. So what is your conclusion? Clearly, my observation X and this blue color observation should not be in one cluster. Clearly, they should not be in one cluster for us. So what is that you are going to do? You are going to put this blue color observation in blue color cluster. And then this red color observation is going to fall, or this observation X is going to fall in another cluster. Because of the concept of greatest distance. Now this is India. Who are the neighbors? You have China, Sri Lanka, Bangladesh, Pakistan. All these are neighboring countries. Suppose there is another country called Malawi in Africa first. So based on the farthest or greatest distance concept, you can understand that Malawi is very far from India. So Malawi country will be part of a separate cluster. Whereas all the other observations, they will be part of one cluster. So that is how you are going to decide. So this concept is called as farthest neighbor concept. So simply, if you want to apply this linkage, you are going to say linkage is equal to complete. Then we will be in a position to apply our complete linkage concept. So now my question to all of you is, if I apply my single linkage and if I apply my complete linkage, what will happen to the dendrogram structure? Are we going to see different dendrogram structures or not? That is the question. So will the linkage impact my dendrogram structure? That is the question. So what is the answer to that question? The answer is yes. Your linkage is going to impact your dendrogram structure. So practically we are going to see in Python what is going to happen when you change your linkage. Your dendrogram structure is going to change first. Is going to change. So keep that concept at the back of your mind. When you change the linkage, your dendrogram structure is going to change. Now, what is the third type of your linkage? It is called as average linkage. So this is cluster A. You have some observations in cluster A. This is cluster B. You have some observations in cluster B. Now find out the distance between your observation X and members present in both our clusters. Find out the distance and then take the average of distances. Then take what is the average distance for your observation X with respect to cluster A, and also take the average distance with respect to cluster B. So to whichever cluster your observation X is having lesser distance, your observation X is going to belong to that cluster. To whichever cluster your observation X is having a lesser average distance, to that cluster, your observation X is going to belong. That is how you can link your observation X with your existing clusters. That is what you are going to do. So it depends on the average of all the distances between members of two clusters. So you can program this logic using linkage is equal to average first. This is what you can do. Linkage is equal to average first. So what is the last type of linkage that you are going to see? It is called as centroid linkage first. Centroid linkage. So what do you mean by centroid linkage? You have two clusters, A and you have B. Now, if you want to decide where this observation is going to fall, simply find out the distance between your observation X and cluster center A. Find out the distance between your observation X and cluster center B. To whichever cluster center your observation X is close to, your observation X is going to fall in that cluster. It is going to fall in that cluster first. That is the concept of centroid linkage, the distance between your centroids. So you have to find out the distance between your observation X and cluster center A and cluster center B. So how are you going to find out your cluster center A and cluster center B? Simply take the average of your observations. So what is the center? X1 plus X2 plus X3 by 3. Y1 plus Y2 plus Y3 by 3. This is the center of our cluster. So take the average of how many ever observations you have and then that will form your cluster center. Now, how can we apply these concepts on our data set? How can we apply these concepts? So what is our data set? It is a university data set. So let us try to understand what is this data set, what kind of values our data set is having. So you have 25 universities in our data set. Brown University, Caltech University, Carnegie Mellon, Columbia, Cornell, all these universities you have. And then you have the corresponding features for every university. What is the SAT score? What is the top 10? What is the acceptance rate? What is the student faculty ratio? What are the expenses and graduation rate? Now, as a student, you want to apply to these universities. Now, when you randomly apply to all the 25 universities, what will happen? You are wasting $100 per application, and also you are wasting a lot of time. So what is that you are going to do? You are going to form clusters on this data set. So clusters are going to help you. What are the universities which are similar together? And once you understand the similar universities, then you can study what are the requirements for those similar universities. What is the average SAT score? What is the average acceptance rate? What is the average semester fees? After studying the requirements of similar universities, then you have to decide, can I apply to that university cluster? Will those universities give me application? Will I get a chance to enroll or to join that university? That is the question. So you can decide on the basis of forming your clusters on your data, identifying what are the similar universities, and then finding out what are the requirements for every cluster of universities. And then you have to decide. So this is the problem statement. This is what you are supposed to do. Now, what is the first thing that you are going to do? Find out the similarity between our observations. How are you going to find out the similarity between our observations? Simply find out the distance between our universities. What is the formula that you are going to use to find out the distance between universities? Euclidean distance formula you are going to use. Euclidean distance formula. So for example, I'm considering two universities, Caltech and Cornell universities I'm considering. And this is the SAT score required for Caltech. This is your acceptance or top 10 percentage. This is your acceptance rate, student faculty ratio, semester fees, and your graduation rate. So find out the distance between these two universities. What is the formula you are going to apply? Euclidean distance formula. So find out the distance. 1415 minus 1280 whole square plus 100 minus 83 whole square plus 25 minus 33 whole square plus 6 minus 13 whole square. So you are going to find out what is the answer when you solve for this distance. So what is the answer that you are going to get? You are going to get this big number, 41,000. So before we understand what is this number. The time is 7:30 now. So I request all of you to fill your attendance sheet. Attendance sheet will be circulated very soon, and try to fill in your details for today's session. So we have our attendance sheet here. Now, we got this very big number of 41,711.22 furrows. This is the 6-dimensional Euclidean distance between my Caltech University and Cornell University. So my question to you is, this number is very big. So it becomes very difficult for us to interpret this number. So why are we getting this big number in the first place? Because your features or your dimensions are having different measuring units. They are having different measuring units for us. So what is causing a problem? Because your dimensions are coming from different measuring units, they are causing a problem of scale. So they are having a problem called as scaling issues. They're coming from different dimensions altogether. For example, your semester fees is measured in thousands of dollars. This is one scale. Your graduation rate is measured in percentages. Your SAT score is measured on a different scale of 1600. So they are having different measuring units now. Because of that, we are getting this big number, 41,711.22. So it becomes very difficult for us to interpret this number. So how can you make all your dimensions unit free? How can you make all your features unit free? How can we do that? Simply by standardizing your data. So what do you mean by standardizing our data? It is converting our data into z-scores. So our job is to convert our data into standardized values. Convert our data into z-scores. That is our job. So Euclidean distance is influenced by different measuring units. It is influenced by different measuring units. So what is that you can do? You can standardize your data. So standardizing my data is nothing but converting my data into a z-scores first. So what is the formula of z-scores? Z is equal to x minus mu by sigma. So you would have discussed this in your basic statistics concept. Z is equal to x minus mu by sigma, converting them. So first let us discuss the concept of standardization first. So we have our formula, standardization. So you have to go to every column. For example, go to your SAT score column and use our formula x minus mu by sigma. What is that you're going to do? Use our formula x minus mu by sigma. Convert your data into z-scores. This is what you are going to do. So like this, I have to go to every column, my top 10 percentage, my acceptance ratio, my student faculty ratio, my expenses and graduation rate. So these are my standardized values that I have. Standardized values. for my Caltech University, for my Cornell University, standardized values. Now, what I can do, now I can find out my distance because I have converted my data into z-scores first. So manually, it is going to take a lot of time for us. So in Python, what is that you're going to do? From sklearn dot preprocessing, import standard scalar, you're going to see. And then you can use this function and fit and transform your data. Then you will be able to convert your data into z-scores. We are going to see this in our Python Jupyter notebooks. Now, after standardizing our data, find out the distance between Caltech and Cornell. So now it is more comfortable for us because we have to deal with smaller values. And then what is the distance that you are getting between our two universities? 3.8. So this is what you are going to do. Before computing your distance, you are going to standardize your data. And then you are going to find out the Euclidean distance. That is the logic. So when you are working with numerical data, this is okay for us. When you are working with numerical data, this is perfectly fine. I can use the concept of Euclidean distance. What if I'm working with discrete data? What if I'm working with categorical data? Then what is the solution? When I'm working with my categorical data, and this is binary data, that means you have your responses which are going to take two values for us, yes or no. So this is the data set that I have. Now I am working with my binary data, yes and no. This is the information that I have. Now imagine that you have three friends, Carrie, Sam, and Miranda. And based on our three characteristics, we have to find out the similarity between our friends. What are the three characteristics? Married, smoker, and manager. So what is the data set? What are the values that you have? So Carrie is a married person. Carrie is a smoker. Carrie is a manager for us. Sam is not married. Sam is a smoker. And Sam is not a manager for us. Miranda is not married. Miranda is not smoker. Miranda is a manager for us. Now, let us try to find out the similarity between our two friends, Carrie and Miranda. So first try to create our 2 cross 2 matrix. So your row names are going to be no and yes for us. These are your row names. And your column names are going to be no and yes for us. So you have your row names, you have your column names. So now try to fill the 2 cross 2 matrix by using the data that you have. So how many times Carrie is saying yes and Miranda is saying no in our data? So Carrie is saying yes and Miranda is saying no. How many times? 2 times. So fill in the answer as 2. So how many times Carrie is saying yes and Miranda is saying yes? 1 time. Carrie is saying yes, Miranda is saying yes, 1 time. How many times? Carrie is saying no, Miranda is saying no. How many times it is happening? 0 times. Carry is 7, never saying no. So 0. Like this, you are supposed to fill your matrix or fill our matrix. Now compare this matrix with another matrix with values A, B, C, D. Compare with your A, B, C, D matrix and find out what is the value of A, B, C, and D. What is the value of A? The value of A is 0 for us. A is 0. What is the value of B? B is 0 for us. What is the value of C? C is 2 for us. What is the value of D? D is 1 for us. This is the information that you have. Now find out first what is the binary Euclidean distance between my two friends Carrie and Miranda. So what is the formula for binary Euclidean distance? B plus C by A plus B plus C plus D. What is B plus C? 0 plus 2 by 0 plus 0 plus 2 plus 1. So 2 by 3 is the binary Euclidean distance between Carrie and Miranda, 0.66. Find out what is the simple matching coefficient distance between Carrie and Miranda. What is the formula? A plus T, 0 plus 1 by 0 plus 0 plus 2 plus 1 by 3. What is the distance between Carrie and Miranda? It is 0.33 for us. Now find out what is the Jacquard's coefficient. What is the formula? D by B plus C plus D. 1 by 0 plus 2 plus 1. 1 by 3. 0.33. So we have found out the Euclidean distance. We have found out the simple matching coefficient. We have found out the Jacquard's coefficient. Now let us try to understand one by one. What do we mean by binary Euclidean distance? So binary Euclidean distances capturing the dissimilarity between my friends. How dissimilar are they? B and C. This is B, this is C. So whenever Carrie is saying no, Miranda is saying yes. Whenever Carrie is saying yes, Miranda is saying no. So it is capturing the dissimilarity between our friends. Binary Euclidean distance metric. So they are 66% dissimilar from each other. What about your simple matching coefficient? Simple matching coefficient is capturing the similarity between our friends. Whenever Carrie is saying no, Miranda is saying no. Whenever Carrie is saying yes, Miranda is saying yes. So they are 33% similar to each other. That is the information what you are getting from simple matching coefficient. What is the information that you are getting from Jacquard's coefficient? So in how many cases both your Carrie and Miranda are saying yes together in our data? So 33% of the time your Carrie and Miranda are saying yes together. In 33% of the cases, your Carrie and Miranda are saying yes together. That is the information what you are getting from Jacquard's coefficient. Now, you can use these measures when you are working with your binary data. But what if you have more than 2 categories? Then what is that you're going to do? If you are working with more than 2 categories, suppose you have 4 categories: petrol engine, diesel engine, LPG, CNG. These are the different types of engines you have. Now you are working with 4 categories. Then how will you find out the distance with respect to our categorical variable? So you are going to consider that distance between my 2 records is going to be 0 if my items are belonging to same category. Suppose, for example, the distance between my observation 1 and 5 is going to be 0 because both my observations are belonging to petrol category first. What about distance between 1 and 2? The distance between 1 and 2 is going to be 1 because both my observations are belonging to different categories first. That is what you are going to do. Both my observations are belonging to different categories. That is how you can extend the logic for more than 2 categories if you have in your data set. Now, what if you are working with mixed data? If you are working with numerical data, so these are all my numerical columns that I have. Then I have my categorical data also. Petrol engine, diesel engine, LPG, CNG, petrol. So what if I'm working with my mixed data? Numerical plus categorical data. Then I can use a concept called as Grover's general dissimilarity coefficient. This is the concept I'm going to use. So this concept uses Grover's general dissimilarity coefficient denoted by Wij. This is the coefficient. Now this will comment on the dissimilarity between our observations. For example, if you want to compare the distance between our two observations 1 and 2, they are having two different types of engine, petrol and diesel. Now, when you're trying to compare two different categories, the coefficient value is going to become 1 for us. So Wij can take values 1 or 0. So if you're trying to compare with two different types of engine, two different categories, it is going to assume a value of 1. So if you substitute a value of 1 here in our equation, then you will be left with only this term, Dijk. So with respect to our types of engine, you can understand that you are comparing two different observations because they are having two different types of engines. So therefore, with respect to your categorical variable, your Grover's general dissimilarity coefficient is going to take a value of 1, and your equation is going to become equivalent to Dijk. So how can you find out the distance now between our two observations? Simply use our Euclidean distance formula because all of them are numerical columns. So for all the other numerical variables, simply you can standardize them and then apply the concept of Euclidean distance. And that is how you can find out the distance between our two records, 1 and 2. So this method is called as Grover's general dissimilarity coefficient. So what is our final conclusion now? Our final conclusion is we have to use the concept of distances and linkages. And using both, we are supposed to create our dendrogram. Once you create your dendrogram, you can decide into how many clusters you want to create your dendrogram. So instead of applying to all 25 universities randomly, I have segregated my observations into respective clusters, 1, 2, 3, 4. And then I can study the requirements of each and every cluster. I can find out what is the average semester fees. I can find out what is the average SAT score. I can find out what is the average graduation rate and then decide to which cluster of universities I can send my applications. This is the concept of your hierarchical cluster. This is what you are going to do. Now, how can we apply this concept? That is the question. So to apply this concept, let me open my Jupyter notebook. and then we are going to discuss our program. So meanwhile, all of you can try to fill in your attendance sheet for our today's session. So now let us apply the concept. So import our libraries, NumPy, Pandas, import our matplotlib library, and then read your file, university underscore plus. So this is our data set that we have. So all our 25 universities are there. Then I have discussed the concept of standardization with you. So you can also normalize your data. This is another way of making your dimensions unit free, making your features unit free. So normalization, when you apply, all the values will be converted into a number between 0 and 1. When you apply your normalizations, all your values are going to be converted into a number between 0 and 1 for us. So what is the formula of normalization? X minus minimum of x divided by maximum of x minus minimum of x. This is normalization formula. So we can define our custom function and you can apply this on your university data set, starting from column 1 onwards, because 0th column is having our university names. So you cannot apply on non-numerical data, your normalization function. So apply that. So if you don't want to define your own custom functions, you can also take the help of ExcelR library. It has a ready-made function called min-max scalar. Initialize your min-max scalar function, fit it and transform on your data set. So all your values are going to be converted into normalized values between 0 and 1. So you have these values. Now, from your scientific Python library, we are going to say from scipy.cluster.hierarchy import linkage. This is a function what you're going to use to create your linkages. And you can say import scipy.cluster.hierarchy for creating your dendrogram. Then apply your linkage function on your data set. You want to create your linkages, right? So I want to create my linkages. What type of linkage I want to create? Average linkage. And metric is equal to Euclidean. Use my Euclidean distance, use my average linkage and set up my linkages. And now on this, I'm going to create my dendrogram. So on my linkages, I'm going to use my dendrogram function and I'm going to create my dendrogram structure. So this is my dendrogram structure that I have. So these are my clusters. So I can divide my data set into 5 clusters, starting from 0 and going up to 4. Total 5 clusters you have. Now, we are going to say from sklearn cluster, sklearn library, and import agglomerative cluster. This is your function for hierarchical cluster. So how many clusters you can create on your data set? 5 clusters. That is what we have seen from your dendrogram. And linkage is equal to complete, and distance measure is Euclidean, and fit it on your normalized data set. Now, once you have fitted your agglomerative clustering on your data set, find out what are the cluster labels for all your observations. So find out to which cluster my observations are going to belong. So Brown University belongs to cluster 3, Columbia belongs to cluster 3, Cornell belongs to cluster 3. So I have all these universities who are falling in cluster 3. Now come down, and what is that you are going to do? Find out what is the mean of every cluster. Group all your observations by their cluster labels, and then find out what is the average for every column corresponding to every cluster what you have created. So if you look at your cluster 1 universities, what are cluster 1 universities? They require only 1061 SAT score. Semester fees is also less, only $9,953 per semester. Graduation rate is 71. Acceptance rate is very high. So if 100 people are applying, 70% of them are being accepted in that university. So if my score is 1050, then what is it I can understand? I can easily apply to my cluster 1 universities. And definitely I'm going to get my admission, because the average SAT score required by this cluster universities is only 1061. So if you scroll up, you can find out what are the universities which are falling in cluster 1 for us. Wisconsin, score required is 1085. Texas Arlington, score required is 1075. Purdue University, definitely you are going to get into Purdue University, because your SAT score is 1050 and Purdue is requiring only 1005. So you can apply to Purdue University. All universities belonging to cluster 1, you can definitely apply. Penn State University. Again, the score required is only 1081 first. So you can apply to these 4 universities and you can wait for your admission, because there is a very high chance that you are going to get admission from these universities. So that is how you are going to decide. So based on clusters, you have identified that 4 universities are falling in one cluster: Penn State, Texas A&M, University of Wisconsin, and Purdue University. So what you can do, you can apply to these universities and then you can wait for the admission. And you're definitely going to get an admission, because you are satisfying the requirements of all these 4 universities. That is the idea. That is how clustering can be used to take business decisions first. That is the idea of your clustering concept. So please try to fill in your attendance sheet for today's session. And that's all what we have for today. Thank you all for joining today's discussion. And tomorrow we are going to start off with another topic and we'll continue our course on data science. So till then, take care, stay safe, and good night.